Hello everyone. Today I'm going to be starting upon a lot of requests actually. I'm going to be starting my 5-part series on calculus. So just a rundown of what everything's going to be. This first lesson is going to be on limits, then differentiation by first principles, then the exponent rule for differentiation, then the exponent rule for integration, and real-world applications of calculus. So today I hope to start by limits and then we can go from there. Okay. So quick history lesson basically. Calculus, it's still actually debated on who actually invented it. And the two main culprits are a guy named Isaac Newton and a guy named Leibniz. It's highly debated on who actually invented it. There's a lot of internet debates. I'm not going to say who I think it is, but the notation that we use today is Leibnizian. It's made by Leibniz, the notation that we use. So yeah. So basically, what the fundamentals of calculus are is the idea of infinity. So basically, whenever someone, this thing didn't exist, no such thing. Whenever that appeared anywhere in maths, people just assumed there was some kind of error and people just ignored it and chose to do different calculations. But then Newton comes along and says, well, basically, I don't like that. So instead of using infinity, it's going to replace it with a letter, and let's just say that's n. So essentially what he's saying is that because infinity can't be represented, he's just saying that n is just a number that's getting really, really close to infinity, like that. Yeah? So let's say we have a graph, yeah? And this is the graph. And we want to work out the area under that graph. Now normally in Key Stage 4, we'd learn, or Key Stage 3 even, we put bars under the graph. Yep, like that. And we basically get told that we draw these bars and we work out the area of these bars, and we add that all together to get the area under this graph. Similarly, if we want to work out the gradient of any point on the graph, so let's say I want the gradient of the graph from that point, I'll mark it as x. We basically have to draw a tangent, yep, and work out the gradient of that. However, that's Key Stage 3 and 4 and boring. So basically Newton was like, I don't like that because it's not very accurate. If we have this line, we have no idea how accurate it is compared to the real thing because we're just drawing a tangent. It's not accurate. Similarly here, we know that the closer, the smaller these bars get, we know that they get more accurate. The more bars you have, the more of an accurate representation you have of this. So basically, Newton basically said, or Leibniz, that the closer that the distance between these bars gets to 0, as in the more bars that appear, the more accurate the more accurate the area will be. So how we notate that is limits, lim. Okay, so let's say I have something like lim of n approaching 0, or lim of n approaching infinity. What that means is we can't use infinity. However, we'll assume that n is getting closer and closer to infinity, or n is getting closer and closer to 0. What that means is n can't ever be 0, but it's getting as close as it possibly can to it. Similarly here, n can never be infinity, but it's just getting as close to it as it possibly can, just to allow our calculations to work. Similarly, with this line of the tangent graph, how do we normally work out the gradient? We do delta y over delta x, don't we? Change in y over change in x. However, there's only one point. So the distance between the 2 points that we're measuring, the distance between them is approaching 0. It can never be 0, but it's approaching it, isn't it? That's basically the fundamental of calculus, and that's what a limit is, the limit. Okay, that's all for today's lesson on limits, and see you next lesson.